Hi friends, welcome back to the channel. In this video we are going to discuss about the HMWS and SB 2020 civil engineering paper. The exam conducted on 12th November 2020. Our discussed paper is set C. Before going to the video, please subscribe to channel and follow us on Instagram. First question is the outlets which maintain a constant discharge irrespective of the fluctuations in the water supply channel and water course is known as A. Semi-modular outlet, B. Kennedy gauge outlet, C. Rigid module, D. Non-modular outlet. The types of canal outlets are: first one is the non-modular outlet, semi-modular as flexible modular, rigid modules. The non-modular outlet is the discharge depend upon the head difference between the distributary channel and water course. So the discharge is depending on the distributary channel and water course. Next one is semi-module. In this, discharge is independent of the water level of the water course but dependent on the distributary. In our question, constant discharge, rigid module. Rigid module is which discharge is constant and fixed within the limits irrespective of the fluctuations. In the question given that maintain a constant discharge irrespective of the fluctuations. So our answer is rigid module. Option C is the correct answer. This is from irrigation. Next question is the rate of seepage Q through an earth dam obtained from a flow net is given by the following equation. This is also from irrigation. A. Q equal to KH into NF by ND. B. Q equal to K into NF by ND. C. Q equal to KH into NF by ND. D. Q equal to H into NF by ND, where K equal to coefficient of permeability of a soil, H equal to total head causing the flow, NF is the total number of flow channels, ND is the total number of potential drops. In this, we know that the seepage flow formula is Q equal to KH into NF by ND. Our answer is A. Here 1 by 2 is by mistake it came. Answer is Q equal to KH into NF by ND. Next question is the Lacy general regime flow equation is given by the following equation. This is also from irrigation. A. V equal to 35.5 into R by S whole to the power of 1 by 2 root RS, and B equal to V equal to 10.8 into R to the power of 2 by 3 S to the power of 1 by 2. C. V equal to 1 by 6 R to the power of 2 by 3 S to the power of 1 by 2. D equal to V equal to 1260 R square into S. Our answer is B. V equal to 10.8 into R to the power of 2 by 3 into S to the power of 1 by 2. Next question is the identify from the following which Indian code book is used for determination of evaporation from reservoirs. In this HMWS 2020 paper, there is 3 IS code books names are asked. First one is the evaporation from reservoirs, next one is the design mix, and another one is the water tanks. For this question, evaporation from reservoirs, IS code book is A. 6966 1989 year, B. 6926 1973 year, C. 6939 1992 year, D. 6955 1973. Our option is C. 6939 1992. And the IS code books are explained in our channel. Please check the video given in the description. Next one is the water is released at the rate of 12 cumec at the head of a canal if duty at the field is 1250 hectares per cumec and loss of water in transmit is 0.25%. Find the area of the land that can be irrigated in hectares. A 1.125 into 10 to the power of 4, B 1.125 into 10 to the power of 2, C 1.125 into 10 to the power of 8, D 1.125 into 10 to the power of 6. Going to the video, first given that Q head is 12 in 12 cumecs, which means meter cube per second. Next one is the duty of the field 1250 hectares per cumec and loss of water is 0.25 percentage, which is 25 percentage, 0.25, and efficiency is 75 percentage, 100 minus 25, which is 75 percentage. Q equal to 75 percentage of the Q head, which is 12 into 3 by 4, 4 3s are 3 3s are 9 cumecs, and Q equal to area by del duty. Area equal to Q into duty. Q equal to 9 cumecs and duty equal to 1250 hectare per cumecs, and cumecs cancel. 9 into 1250 equal to 11,250 hectares, which is 1.125 into 10 to the power of 4 hectares. Our option is A. Next question is the from which river the water has been lifted to Kondapochamma reservoir? A. Godavari, B. Musi, C. Kaleshwaram, D. Krishna. A. Godavari river. The lift Kaleshwaram lift irrigation constructed on the Godavari river. B. Musi. Musi is birth at Vikarabad district, Anantagiri hills. C. Kaleshwaram. Kaleshwaram is a place where the Pranahita and Saraswati, these rivers are merging at this place. Krishna is entering in the Gadwal district. Godavari is entering in the Nizamabad district. Musi is in Vikarabad district. Kaleshwaram is a location name. So Kondapochamma reservoir is in the district of Siddipet. It is constructed on the Godavari river. Our option is A. Next question is the total hardness value obtained from the complete analysis of a water sample is found to be 117 mg per liter. The analysis further showed that the concentrations of all the three principal cations causing hardness are numerically same. Value of the carbonate hardness is 57 mg per liter. Calculate the value of non-carbonate hardness is A. 6 mg per liter, B. 117 mg per liter, C. 50 mg per liter, D. 60 mg per liter. Given that total hardness is 117 mg per liter and the carbonate hardness is 57 mg per liter and non-carbonate hardness, we have to find this. Total hardness equal to carbonate hardness plus non-carbonate hardness. Given that total hardness is 117 equal to 57 plus non-carbonate hardness, we will get non-carbonate hardness equal to 60 mg per liter. Our option is D. This is from environmental engineering. Next question is the units of turbidity is A. Nephelometric turbidity units, B. Threshold number, C. Gram per liter, D. Unitless. The option A itself consists of turbidity units, so maybe the option A. Next one, threshold number. Threshold number is used for odor. Gram per liter. Gram per liter is, we know that it is the density units, kg per meter cube. 1 meter cube equal 1000 liters. D. Unitless. So the option itself consists of A. Nephelometric turbidity units. Our answer is A. Nephelometric turbidity units. This is also from environmental engineering. Next one is the identify water distribution system among the following. This is also from environmental engineering. A. Reticulation system, B. Radial system, C. Combined gravity and pumping system, D. Tree system. We know that water distribution systems are which is the gravity system, pumping system, and combined gravity and pumping system. These are water distribution systems. Layout of water distribution systems are tree system or dead end system. This is one. Reticulation system, this is 2. Radial system, 3. And fourth one is the ring system. So our option is C, combined gravity and pumping system. These A, B, D are the layout of the water distribution system. These are the combined gravity and pumping system. The combined gravity and pumping system we used at the villages. From overhead tank to the houses are, the distribution of overhead tank to houses is based on the gravity, and the motor pumping well to and the overhead tank is on the based on the pumping system. So it is the combined gravity and pumping system. Option C is the correct answer. Next one is the during certain period the load on the hydel power plants varies from 15,000 to 35,000 kilowatts. Calculate the load factor. Load factor is given that average load by peak load. Here average load is the 35,000 plus 15,000 by 2 divided by peak load is 35,000 kilowatts. We get 25,000. 35,000 by 35,000 plus 15,000 by 2 equal to 50 by 2. 25,000 by 35. 5 5s are 5 7s are. Our option is 0.7143. Option D is the correct answer. Next one is the a gate consists of 2 leaves of timber or steel hinged and sealed to the spillway crest is called as A, tainter gate, B, rolling gate, C, bear trap gate, D, drum gate. This is the 2 leaves, solid upper leaf and the buoyant lower leaf. The 2 leaves consist of a gate is known as bear trap gate. This is the bear trap gate. Option C is the correct answer. Next one is the consider the following items: A, intakes, B, water treatment plant, C, service reservoirs, D, control valves, E, hydrants. Choose the correct answer related to the components of public water supply system. Intakes, water will be taken from the rivers, and water treatment plants, the supply collected water will be treated before the distribution. Service reservoirs, the treated water stored in the service reservoirs, nothing but overhead tanks. Check control valves, the valves used for the distributary system. Hydrants, these are the fire hydrants, like that. So A, B, C, D or A, B, C, D, E are the correct for public water supply system. So our option is B. Next one is the horizontal flow velocity in a sedimentation tank passing a discharge Q and having length L, width B and depth H is given by. This is also from environmental engineering. A, Q by B into 1, B, Q by L into H, C, Q by B into H, D into Q by BL. We know that Q equal to area into velocity. Here we are finding velocity V equal to Q by A, which means the water is flowing from this side, horizontal flow velocity, this side. This is the width B, height H, length L. Water is flowing from this side and the area is taken as this area, B into H, and Q is the discharge. The horizontal velocity is Q by B into H. If here asking horizontal flow velocity, if they asked us the settling velocity, if settling velocity asks, we can find out this area. This is the width B and length L. Q by BL is the for settling velocity. Here asking the horizontal flow velocity. So our answer is Q by BH. Option B is the correct answer. Q by B into H. Next question is particulate matter, fly ash, carried in effluent gases from the furnaces burning fossil fuels are better removed by A. Cotton bag house filter, B. Electrostatic precipitator, C. Wet scrubber, D. Cyclone. In this, electrostatic precipitator gives the 95 above efficiency in the removal of particulate matter. In the electrostatic precipitator, the inner particulate matter flowing in this direction, the metal plates are showing like that. In this, the metal plates have the positive charge and the particulate matter have negative charge. So this will attracts, the plates will attract the particulate matter and outgoing gas is particulate free matter. So our option is electrostatic precipitator, B. Next one is the two primary air pollutants are A. Sulfur oxide and hydrocarbons, B. Ozone and peroxyacetylene nitrate, sulfur oxide and ozone, D. Nitrogen oxygen and peroxyacetylene nitrite. In the primary pollutants, carbon monoxide, carbon dioxide, sulfur dioxide, nitrous oxide, nitrous dioxide, most hydrocarbons, most suspended particles. Secondary pollutants are ozone, sulfur trioxide and H2SO4. So we know that ozone is secondary pollutant. In this, say ozone is there. B. In the C also ozone is there, and in the sulfur dioxide is primary pollutant and hydrocarbons are the primary pollutants. Our option is A. Next one is the environmental engineering question. The design technique adopted in design of large water supply networks as an aid to supply and separate the smaller loops is A. Circle method, B. Hardy-Cross method, C. Electric network analyzer method, D. Equivalent pipe method. Our answer is equivalent pipe method. Option D is the correct answer. Next question is the which valve is placed in a pumping main so that if pump fails or stops, water is prevented from flowing back to the pump and thus pumping equipment is saved from the possible damage. A. Reflex valve, B. Air relief valve, C. Sluice valve, D. Pressure relief valve. In this, we use the return flow by using the reflex valve or check valve. In this, the water is flowing in this direction and the return reverse flow is obstructed by closing the valve. So our answer is reflex valve or check valve also we know. A. Option A. Next question is the assertion reasoning. A. Slow sand filters are more efficient in removal of bacteria than rapid sand filters. Yes, slow sand filters give 98% of efficiency removal of bacteria and rapid sand filters give 80 to 90% of efficiency in removing the bacteria. Option A is correct. Assertion is correct. Reason: the sand used in slow sand filters is finer than that in rapid sand filters. Yes, slow sand filters sand is finer than the rapid sand filters. We know that D10 values are very less for the slow sand filters than the rapid sand filters. Effective diameter of the sand is very low for the slow sand filters. Our option is C. Both A and R are true and R is the correct explanation of A. Next question is the according to Indian Roads Congress, the maximum width of road vehicle is A 2 meters, B 3.8 meters, C 2.65 meters, D 2.44 meters. In this, width of a road vehicle is 2.44 meters as per IRC. Our option is D. Our option is D. Next one is the, in which year Motor Vehicle Act was brought into effect by Government of India to regulate the road traffic in the form of traffic laws, ordinances and regulations? A 1949, B 1939, C 1959, D 1929. Our option is 1939. In 1939, first Motor Vehicle Act was passed, and 1988 the 1939 Act was revised or replaced. So our option B is the correct answer. 1939 Motor Vehicle Act. 1927 is the Jaker committee will be appointed. 1929 is the, they given the report on the road safety. So our option is Motor Vehicle Act 1939. The second 20-year road development plan 1961 to 81 is also called as A Bombay Road Plan, B Nagpur Road Plan, C Lucknow Road Plan, D Delhi Road Plan. These are transportation questions. Road development plans: Nagpur Plan 1943, 20-year road plan Bombay Plan 1961 to 81, 20-year road plan development plan Lucknow Plan. First road plan is Nagpur Road Plan 1943 to 63, but before that it completed in the 1961. So again they planned the 20-year road plan 1961 to 81. This is the Bombay Road Plan. Next 1981 to 2001 it is the Lucknow Road Plan. In Nagpur Road Plan, they wanted to construct a roads of 16 kilometers per 100 square kilometer area. In the Bombay Road Plan, they wanted to construct 32 kilometers per 100 square kilometer area. In Lucknow Road Plan, they wanted to construct 82 kilometers per 100 kilometer square area. Road densities. This is the road density of Nagpur Road Plan is 16, Bombay Road Plan is 32, and the Lucknow Road Plan is 82. Our option is, we know that 1961 to 81 second road plan is Bombay Road Plan. Option A is the correct answer. Next one is the, what type of noise can be abated by providing lining on walls and ceiling with sound absorbing materials? A reflection noise, B structural noise, C direct airborne noise, D source noise. This is from environmental engineering. We know that lining on walls and ceilings with sound absorbing materials, we can restrict the reflection noise. We see that in the movie theaters and YouTube studios, they use the material which is absorbing the sound, so reducing the reflected noise. So our option is option A, reflection noise. Next one is the, read the following statements related to road alignment. A improper alignment would result in increasing the construction cost. Yes, it is correct. Improper alignment would result in the construction cost. Improper alignment would result in the increase in maintenance cost. Yes, it also correct. Maintenance cost will be increased due to the improper alignment. Improper alignment would result in decrease in vehicle operation cost. No, this is wrong, because improper alignment means they are paying the road without following the guidelines. So it will increase the vehicle operation cost. Improper alignment would result in increase in the accident rate. Yes, if they are not following the IRC rules, they may provide the gradient wrong, or maybe horizontal curve elevations are wrong, super elevations. So it may cost us the accidents. Identify the wrong statement. We know that option C is the wrong statement. This is not, vehicle operation cost is increases with the improper alignment, not it is decreases. So our option is C. Next question is the required camber of pavement depends on A type of pavement surface, B. The amount of rainfall. C. Longitudinal slope of the road. D. Traffic volume. In this, camber means the elevation across the road. The slope across the road is known as camber. We know that so longitudinal slope is not correct. Option C is neglected. We can see in the option C is in the B and D. So we can neglect B and D options. We have A and D and A and B. In this we can see that this is the parabolic camber, this is the straight line camber, combination of straight and parabolic camber. As per IRC values, camber is provided for different roads, concrete or bituminous surfaces, gravel and WBM, earthen. So it is based on the heavy rainfall and light rainfall. For light rainfall, it is provided 1 in 60. This is 1.7 means 1 in 60. This is 1 in 50 heavy rainfall. This is 1 in 40 and 1 in 33. This is earthen 1 in 33 and 1 in 25. So it is based on the rainfall, also the type of pavement. So option C is the correct answer. Option C is the correct answer. Next question is the Indian Railways is the world leader in the manufacture of which type of sleepers? A. Concrete, B. Steel, C. Cast iron, D. Wooden. Our answer is concrete sleepers. Indian Railways is world leader in the manufacturing of concrete sleepers. These are the concrete sleepers. These are the rails. We know that these are the rails. So our answer is A, concrete sleepers. Next question is the identify the correct formula for the calculation of safe speed on transition curves for broad gauge and meter gauge in km per hour using the following equation. A. V equal 2.4 into root r minus 70, V equal to 4.4 into root r minus 70, V equal to 4.4 into root d minus 70, D equal to D, option D, V equal to 2.4 into root d minus 70. We know that we can take radius in the formula. The answer is B. V equal, this is the standard formula, V equal to 4.4 into root r minus 70. B. Next one is the wear on rails is more predominant at some locations. Study the following points related to this. A. On sharp curves. Now, sharp curves due to the super elevation, the wear may be occur. B. On steep gradients. Due to the gradients, the rails may be wear. C. On approaches to railway stations. Due to the braking effect, the rails will be wears. In tunnels and coastal areas due to the salty water, the rails will corroded quickly. So A, B, C, D are correct. So our option is wear on rails is based on more predominant sharp curves, steep gradients, approaches to railway stations and tunnels and coastal roads. Our answer is A, B, C, D. Next question is the calculate the safe stopping distance for a design speed of 36 kmph for two-way traffic on two-lane road. Assume coefficient of friction as 0.25 and reaction time of driver as 2.5 seconds. Take G equal to 10 meters square per second. A 45 meters, B 40 meters, C 20 meters, D 25 meters. This is from transportation. Solution. V equal to velocity equal to 36 kmph. It is converted to meters per second, 10 meters per second. Next, two-lane, two-way traffic. Next, F equal to 0.25 coefficient of friction. T equal to reaction time of a driver equal to 2.5 seconds. We know that take G equal to 10 meters square per second. Stopping side distance equal to Vt plus V square by 2gf. SSD equal to 10 into V equal to 10 meter per second into 2.5, T equal to 2.5 plus V square 10 square by 2gf, g equal to 10 meter square per second, f equal 0.25. We get 10 into 2.5 is 25, 100 by 2 into 10 into 2.5 which gives 50. 50 by 100 equal to 1000, sorry, 10 square 100, 20.25, 0.5, 5 by 100 is 20, 25 plus 20 is 45. Our option is A. 45 meters is the correct answer. Safe stopping distance is 45 meters for this question. Next question is the A. What is the maximum contact shear stress F at the contact point between the wheel and the rail is given by the empirical formula? A. 4.13 root R by P, B. 2.13 root R by P, C. 4.13 root P by R, D. 2.13 root P by R, where R is the radius of the fully worn out wheel in mm, P is the static wheel load. Our answer is C. 4.13 root P by R is the answer. This is the standard formula, empirical formula, 4.13 root P by R. Remember this. Next one is the calculate the rate of super elevation for a horizontal highway curve of diameter 1000 and speed of 50 kmph. Rate of super elevation. We know that super elevation here highway curve diameter is 1000, radius equal to d by 2, so r equal 1000 by 2, 500 meters. Next, v equal to 50 kmph. Design super elevation, E equal to v square by 225 r, because this is the rate of super elevation. V square equal to 225 r. E equal to 50 square by 225 into 500. This is for kmph only. E equal to 50 square by 225 into 500, which is 1 by 45. It is equal to 0.022. These are the first 30 questions in the HMWS 2020 paper. We will discuss 31 to 60 questions in the next video. I am giving the option D is the correct answer. I am giving the final answer key of the HMWS 2020 paper, set C. This is the final answer key. Thank you for watching this video. Please subscribe to my channel.